telerobotically operated by people on the ground. They can work autonomously. And of course, when we have human crewed missions, they'll be driven by the humans. These things can go up to 10 kilometers per hour and go up and down slopes of like 20 degrees. So I'm going to get ready to announce the first LTV award winner, and that is Astrolab. Congratulations. Astrolab has adapted its Flex rover architecture to deploy the Crew Lunar Vehicle #1. So give him a round of applause. Congratulations. This new vehicle is smaller, lighter, and can accommodate up to 2 crew, which is what we asked for during Ignition Day, to be able to test and develop the capabilities as we go. Again, it has autonomous capabilities. It can be teleoperated, or of course the crew will drive it. CLV-1 has a maximum mass of 950 kilograms and can reach speeds up to 10 kilometers per hour. Astrolab is also building the Flip rover, which has a lot of the features that will then be carried over to the Lunar Terrain vehicle. Astrolab is using subs like Odyssey Space Research, Axiom Space, and Interloon as the subcontractors for that. So imagine the first rover, because we're going to have cameras, we're going to have payloads, roving around Mars and basically bringing us with them in real life, going to places we have never seen of the moon, testing us and giving us key ground truth data so we can build on that. Again, one round of applause for Astrolab. Congratulations. The second LTV provider, which I'm going to announce now, is Lunar Outpost. In response to NASA's moon-based initiative, Lunar Outpost unveiled a new class of rover called Pegasus, which is what we're going to deliver to the surface of the moon. Pegasus is a pared-down version of Lunar Outpost Eagle lunar terrain vehicle. Pegasus is a lighter weight and will be ready to fly on earlier missions as we've asked and demanded. They will do things like autonomous driving, terrain mapping, and identify future potential moon-based sites. Pegasus can carry up to 2 crew members and travel 10 kilometers per hour on the lunar surface and, like I said, go through steep slopes and terrains. They're partnering with General Motors, Leidos, and Goodyear as key subcontractors for the vendors. So give Lunar Outpost a round of applause. Congratulations. These awards are incredibly important to the next steps of phase 1, because we have to be able to move around the surface and start looking and gaining the knowledge we need to build up on the moon base. Part of that also is Moonfall, which is the lunar drones that we advertised during Ignition Day. Moonfall is the first lunar drone capability that we're going to have, and it's going to accomplish different objectives. The first is demonstrate the technology. It is going to be the first robotic mobile platform with the range to quickly explore sites interesting at the lunar South Pole. Like the administrator discussed earlier, the variances in lighting, thermal gradients are gigantic on the lunar surface. And we basically have a range of like 1 meter dedicated information on the different areas we want to go to. So in that 1 meter, if we're wrong, or if we're off a little bit, those ranges of 400 or 500 degrees in temperature can be a key aspect that we need to overcome. So these drones will allow us to go, cover a broader range of areas that we unprospect and get that ground truth. It can demonstrate the ability to take off and land in multiple locations with precision under South Pole lighting conditions and terrain features. Also, it will utilize available electronics so we can develop them quickly and deploy them where we need. One of the key things that we want to put on these drones is survive the night technology. So not only can they accomplish the mission, they can hop, go to multiple locations, but they can also survive the long lunar nights. So when they get sun again, they can serve a permanent objective wherever they ended up at. It could be observation, it could be communications, or something else. Another key objective is site characterization, so we'll be able to map the surface at centimeter scale resolution, not meters, centimeter scale resolution, allowing us to beef up our orbital databases and reducing the risk for future landings. It will prospect for water and ice in the subsurface of the moon. It can go look into the surface of the moon about 1 meter in depth across tens of kilometers. It will also characterize the radiation environment before we send other assets or crews to the surface and provide a geodetic framework for navigation using retroreflectors. Wherever we put these drones, it will provide much more of a capability for precision landing for whatever landing is coming into that area. And then we'll have cameras, of course, on all of them and be able to observe around the territory. The next objective is imaging. So in the picture that you see on the screen, you have the current capability on the right and what we're going to provide on the left. So high-resolution imagery across all mission phases, including the deployment, the landing, and nominal operations of staying in situ or hopping around. It will continue image collection during extended mission, and it will analyze the different sites for unprecedented detail and basically allowing us to build our understanding of soil mechanics, the terrain, the lighting conditions in situ of wherever we want to go. It will help us build a digital terrain map of different landing sites on the moon and prospect moon-based sites. So all of those things are going to be critical for continuing understanding of where we're going. The last part I wanted to talk about that we're hoping to achieve is to establish a moon-based perimeter. With 4 or 3 lunar drones, Moonfall, we're going to be able to basically put them at the corners of the areas where we think we have either key scientific objectives or we want to build up the moon base. And maybe in their final hope, like I said earlier, we can give them a function, potentially be a beacon, provide those retroreflectors to be able to get more precise landing, even be the first lunar cell tower if we choose to do so. By coupling the survive the night technology with different instruments and of course cameras for observation, it'll give us a tremendous capability. And like I said, for phase 1, Moonbase is just a demonstration of capability. We hope this will work out and we'll be able to evolve that capability. I'm picturing the future of Moonbase where we're starting to plan areas where we're going to send the crews or rovers to robotically go to a specific crater or area of interest. We can deploy these drones. Some areas we can even reach with lunar terrain vehicles or rovers. So this could be a critical capability to allow us to get to those objectives. So something has to take the lunar drones, Moonfall, to the surface of the moon. And today we're ready to announce that JPL, our partner developing the Moonfall drones, has selected a carrier spacecraft, and that is Firefly. All right, congratulations. Big round of applause for Firefly. So Firefly is going to build a version of its Elytra dark orbital vehicle for this mission. Firefly's first vehicle is built on the same systems that successfully landed and gave us that mind-blowing video of reaching the surface of the moon. That was the CLIPS Blue Ghost mission that flew and successfully landed last year. They're working with JPL on the part of the mission called cruise, deorbit, and braking stage. So the Elytra vehicle will basically carry the drums from Earth into lunar orbit, then slow down, and at a certain altitude, it will deploy 4 or 3 drones that will then take the mission on their own hands. They'll finalize the landing. They'll land probably about a mile apart from each other and carry on from the mission there. This is a very exciting mission that you can see a picture of the carrier vehicle there. We can't wait to get started and actually see these things deployed. Congratulations, Firefly, and glad to partner with you guys on this. All right, so we're done with the award announcement, so a big round of applause for all of you. Now gets the hard part, which is delivering on time and having successful missions back to back. Okay, now I want to talk about what is on the lunar horizon. So the first one I want to talk about is CLPS 1.0. During Ignition Day, basically we said we're going to use the CLPS construct, which was doing scientific commercial service payload delivery to the surface, to continue on and provide the landers that will carry our assets to the surface. And we declared 2 things. We were going to contract for the LTV delivery service, which we just announced, and we were going to also expand the number of missions to carry payloads, whether scientific or technology demonstrations. Those announcements are coming back and coming up in June. So stand by for that, and we're going to declare the award winners for several of those missions to add to the Moonbase portfolio. We're also working on additional task orders for low and mid-sized class landers through 1.0 to potentially deliver additional technology demonstration payloads. So all of that is also coming up soon. And then, in Ignition Day, we talked about CLPS 2.0. So 2.0 is really the next generation lunar cargo landers. We are accepting proposals to that June 30th, and early in the fall or even late in the summer of 2026, we'll announce the companies that are eligible to participate on that. And it's going to be a very quick turnaround between making those vendors eligible to when we start contracting those missions. CLPS 2.0 is built on the successes of CLPS 1.0, but we're giving ourselves more flexibility. There's going to be ability to do tax orders on end-to-end service. There's going to be ability to basically just buy a lander and be able to couple that with launch service and also technology demonstration payloads, which we may procure or build on our own, and we'll be doing the integration of all of those missions in-house. Again, full end-to-end service, in-house, or a combination of. And we're going to be using that and advertising providers eligible and missions through CLPS 2.0 with the next generation landers pretty soon in the next coming months. And then one of the things that we were wanting to do pretty fast is basically establish the architecture, set the priorities for the technology that we're going to need in phase 2, and then map that to the tech demonstrations that we need to do in phase 1, all these landers we're just talking about. We've narrowed the field of things that we're interested. There's many things that we need to perform, including survive the night and all of those things, but we really want to focus on developing the mid-sized cargo delivery. This is going to be accomplished through CLPS 2.0. Initial